Proof by induction, part 8. Proof by induction that the sum of squares of odd numbers equals to n times 4n squared minus 1 over 3. To do that, we first of all do step 1 to show that the statement is true for n equals 1. So we look at the left hand side and the right hand side of this equation. For the left hand side, I'm going to replace n with 1, and we know that we go from 1 to 1, so r will be 1 here, so that's r equals 1, and then we'll simplify this, and I give 1 squared, that's 2 minus 1, that's 1 squared, and that equals to 1. For the right hand side, we use the formula here and replace n with 1, and so we get 1 into bracket 4 times 1 squared minus 1 close bracket over 3, and that gives 1 times 3, this is 4 minus 1 over 3, and that equals to 3 over 3, and that equals to 1. Hence, we've proved that this is 1 on the right hand side, and this one too is 1 on the left hand side, and we've shown that the statement is true for n equals to 1. Step 2. Assume the statement is true for n equals k. In that case, we would write the equation down again, and we're going to change n to be equals to k, and then transform this equation from n to k. And so the n here is now k, and n here is now k. The reason why we've done this is because we're going to use this equation for step 3. This is when we find the sum from r equals to 1 to r equals k. Step 3. Prove the statement is true for n equals k plus 1. Here's the equation again. So we're going to transform the n into k plus 1. And now I'm going to write that in terms of k plus 1. And I'm replacing n here with k plus 1, n there with k plus 1. And this is what I need to be able to prove using step 2. I need to use step 2 to show this. I can simplify this by writing 1/3 k plus 1 times that. I need to show that using step 2. This is the equation again. I'm going to now use step 2, which is I'm going from r equals 1 to k plus the last term, which is the k plus 1. So I'm replacing the r with k plus 1. And I need to change that with k. And so that's what we did from step 2, where I replaced that with k, then plus the last term. 2 times k, that's 2k. 2 times 1, that's 2. So go 2k plus 2 minus 1 will be 2k plus 1. So you expand that bracket, then you get that. And now I need to carry on simplifying this. So that's that one here. I just multiply out with the k. 4k cubed minus k times that, and k times that, plus I need to expand that. Now this is 2k plus 1 times 2k plus 1, and that will give us 4k squared plus 4k plus 1, because 2 times 2k is 4k squared. 2k times 1 is 2k. Then if I times that again by itself again, because this is twice of this, so I get 2k, and then I get 1 times 1, that would be 1. That's why it's 4k. Now I need to simplify this. I've decided to write it as 4 over 3k cubed minus k over 3, which is same thing as this, plus the 4k squared plus 4k plus 1. Now I need to simplify again. 4 over 3k cubed plus 2k squared, collecting like terms now, arranging in the power of decreasing power, plus 4k minus k over 3 plus 1. Now I need to multiply this because this is 4k over 1. So if I times that by 3, I need to times that by 3 to make its common denominator because they have the same power of k. 4 over 3k cubed plus 4k squared plus I'm getting 12k over 3 minus k over 3 plus 1. And that would be equal to 4 over 3k cubed plus 4k squared plus 11 over 3k plus 1. This is 4k cubed. And that's a cube as well. Let's write the equation down again, where we got to. So this is where we got to. Now what we need to do is we need to take out a third. If I take out a third, I'm going to get the 4k cubed plus 12k squared. I need to multiply everything by 3. That's what I meant by taking out a third and multiply everything by 3. So if I times that by 3, that 3 will go. If I times that by 3, I get 12. If I times that by 3, I get 11. If I times that by 3, I get 3. So that's what happens when you take out a third. I also need to take out k plus 1 because the final value will be 1 over 3 k plus 1. So I've taken out a third. I need to take out k plus 1. So let's take out k plus 1. And in order to do that, I need to do a factorization process. So this is a function. I need to take out k plus 1. So I need to multiply by k 4k squared to get 4k cubed. So k times that will give me, obviously I'll take it away, k times that will give me 4k cubed. And I need to then do 1 times 4k squared. I get that. I'll draw a line and I take away, so that will be 0. That minus that will be 0. And 12k squared minus 4k squared is 8k squared. And I'll bring that down, bring that down, bring that down. The next thing, I need to make this 0. So to make this to 0, I need to take away. That's what I need to do. So I need to multiply by 8k. K times 8k will give me 8k squared. So I need to take away. So I get 8k squared. So 8k times k is 8k squared. 8k times 1 is 8k. Draw a line, take away. So that will be 0. What I'm doing is eliminating the k cubed, k squared, and k until I get to 0. So taking away, that will be 0. So that's gone. 11k minus 8k will be 3k, and then bring the 3 down, so that plus 3. Now I need to now multiply by plus 3, so 3 times k will be 3k, but I'm going to take that away as well, because I'm going to eliminate it. So k times 3 is 3k, plus 1 times 3, that's 3. Draw a line, so that's good. So that means k plus 1 is a factor of that function. This is what's left. So I've got that. I'm taking k plus 1 out, and I'm going to have that left. So if I come back here, k plus 1, because if I multiply that by that, I get this. So I get 4k squared plus 8k plus 3. Now I need to simplify this. I need to make it look like that. So I got to have minus 1. So I'm going to have k plus 1 squared, 4, and then minus 1. What I need to do is do the expansion with this one and find a way to eliminate 1 from there. And let's do that here. So I've got that function, this one. And what I'm going to do is rewrite that by saying 8k plus 4 minus 1. So 4 minus 1 will be 3. Now I need to simplify this one. If I take 4 out as a common factor, I'm going to get k squared plus 2k plus 1. I'm going to get 4, open bracket, k squared plus 2k plus 1, close bracket. And then I'll get minus 1. So I'm going to take that and simplify that and further. That will become k plus 1 squared. That's what this is, minus 1. So I can take that. I can then put it here. So that will be equal to 1/3 k plus 1, that's that one, open bracket, 4 k plus 1 squared minus 1, close bracket. And that is what I needed to prove using the second process, which I have done. So this is a process that we need to show when we replace n with k plus 1, we get that. We had to use step 2 to derive that. And that's what we've done here using step 2, but it's a kind of winding long process. So from that, from the step 2, we arrived at the formula that we needed to. So therefore, we have proved that the statement is true for n equals k. Step 4, we must write the 4-point statements to get full mark. The first, since the statement is true for n equals 1, must be written down, followed by the second, and if the statement is true for n equals k, must be written down, followed by, then it is true for n equals k plus 1, and finally, the statement must be true for all n greater or equal to 1. All these 4 statements must be written down in order to get the full mark.